Hello, everyone. Welcome back. Today, we are going to be talking about solving and graphing absolute value inequalities. So, first, what we need to do is we need to solve them in order to graph them, essentially. So, let's talk about how we would solve them. Whenever we solve absolute value equations, we always must solve two equations, the equation for the positive or negative, and we have to do something very similar here. We need to solve for 3 minus 9x is less than or equal to 60. And we also need to solve for 3 minus 9x is greater than or equal to negative 60. So in one of them, all I did is I just removed the absolute value bars because that is one possibility, is the positive option. In the other one, I not only removed the absolute value bars, but also switched the sign, right? It switched from less than or equal to greater than or equal because we multiplied a negative 1 through. And then on the right side, instead of 60, we now have negative 60. And so now I need to solve both of these equations individually. So let's start with this first one over here. I'm going to subtract 3 from both sides, and that's going to give me negative 9x is less than or equal to 57. And then we're going to have x is greater than or equal to 57 over 9. Right? Because keep in mind that what I did here is I divided both sides by negative 9. And so whenever we divide a negative through our absolute value sign, we flip the sign. So that's why it has switched from one to another. All right, and next I'm just going to reduce that. I do believe that reduces because we can divide both by 3. So that's going to give me that x is greater than or equal to negative 19 over 3, which is the same as negative 6 and 1/3. Okay, now before we graph that, I'm going to actually find the other solution as well, and then we'll graph them both together. It'll be a lot easier. Okay, so for the second one, I'm going to subtract 3 from both sides first. So I'll get negative 9x is greater than or equal to negative 63. Then I'm going to divide both sides by negative 9. And if I do that, of course, I need to flip the sign. So I need to switch my greater than or equal to a less than or equal to. And then negative 63 over negative 9 is going to be 7. So therefore, less than or equal to 7. So my overall answer is going to be that x must be in between negative 19 over 3 and 7, right? That's the overall answer. So what I'm going to do to graph this then, let's scroll down a little bit to graph this. First, I'm going to put a dot on the boundaries on 7 and also on negative 19 over 3, which is the same as negative 6 1/3. So that's going to be around there. And then everything in between is also a solution. Okay, and also keep in mind the reason I filled in these dots rather than did open circles is because these are greater than or equal to and less than or equal to signs. Because of the equal to part, we want to fill those in. If it were strictly greater or strictly less, then we wouldn't do that. Okay, so I'm just going to go ahead and fill that in. And there we go. That would be our graph. It includes everything that is between those two numbers of negative 6 1/3 and 7, including the numbers themselves. All right, let's try another one. For this one here, it says that x minus 9 in absolute values is less than or equal to 17. So what are the two equations we need to solve here? We need to solve for x minus 9 is less than or equal to 17, and also x minus 9 is greater than or equal to negative 17. So first thing I'll do for this first one, I'm going to add 9 to both sides. And if I do that, I will get that x is less than or equal to 17 plus 9, which is 26. And then for this other one here, I'm going to add 9 to both sides as well. And I'm going to get x is greater than or equal to, let's see, negative 17 plus 9 would give us negative 8. So therefore, this must be greater than or equal to negative 8, less than or equal to 26. So therefore, the answer has got to be between negative 8 and 26. Now you might notice this number line doesn't go that far, so I'm actually going to switch the scale a little bit. This negative 8 can stay as is, that's fine. And we're going to go by, let's do, I think by 2s might not actually give us enough room. Let's do by 3 or 4. Yeah, maybe 4 actually. Let's do 4. So negative 4, 0, 4, 8, 12, 16, 24, 28. There we go. It's a bit of a better scale. And then I'm going to draw a dot on this boundary and also a dot on right between 24 and 28, because that's going to be where 26 is at. And I'm going to fill in this line because everything in between here is where we're going to have our solutions. All right. Let's do a third example. This one is 3x plus 9 in absolute values is greater than 7. So there's a couple differences here. Notice the other two were less than or equal to's. This one is a strictly greater than. So strictly greater than means the boundaries are not included. And also it's going to be greater than, and so that means our set is going to be disjoint. So it's going to be a little bit different than we're used to. It's going to have two separate parts rather than kind of being numbers all in a row together. You'll see what I mean when we actually get to the answer here. All right, so let's do it. We need to solve two equations. First one is 3x plus 9 is greater than 7. And then the second one is 3x plus 9 is less than negative 7. Okay, first thing I'm going to do is subtract 9 from both sides. And that's going to give me 3x is greater than negative 2. Then we'll divide both sides by 3 to get that x is greater than negative 2/3. Okay, cool. So greater than negative 2/3, wonderful. Next, we're going to do the other one. So we're going to subtract 9 from both sides. So same step again. 3x is less than negative 16. And then we're going to divide by 3 on both sides and get x is less than, let's see, negative 5 and a third in that case. Because, yeah, negative 16 over 3 is the same as negative 5 and a third. Okay, so you'll notice here these two things are not together. X must either be greater than negative 2/3 or less than negative 5 and a third. So therefore, x must either be greater than, let's say negative 2/3 is right there. It has to be greater than this, so I would color in all of this part here. There we go. And then I would also color in where is x less than negative 5 and a third. So negative 5 and a third would be right around there. And anything that's less than it, I would also color in this case as well. And so there we go. So it's actually the middle part that isn't shaded in this situation. So that's something we have to be careful of, is should we shade in the middle part or do we shade in everything else? And that depends on which direction our signs go. Also note that here I did open circles instead of closed circles in my boundary, because here we had strictly greater than and strictly less than signs. We didn't have less than or equal or greater than or equal. So that's the reason why these holes are open, whereas these holes over here in the previous question were closed. So that is an important distinction I wanted to make. All right, well, that's going to be it for this one. Good work, everyone, and we'll see you for the next one.